right, Math 1, this is your week 3 homework help video. I'm going to do these two. Not going to do those. You know how to do these. You factor this and you're going to add combine like terms by adding, okay? So now let's look at this one. This is x squared minus x minus 6 divided by 2x squared plus x minus 6. Okay, so in this problem, we're going to factor both the top and the bottom, okay? So on the top, when you factor it, you got two parentheses, x in each. You got to do your factor sum to T-chart. So here, this is going to be -6, and it adds up to a -1. The sum is going to be a -1. So you got 2 and 3, 2 times 3. So in order to make this a negative, the 3 has to be a negative. So -3 plus the 2 is equal to a -1. So this is going to be plus 2 minus 3. Okay, so on the bottom, let's do the bottom. Okay, so I'm going to factor this out to the side. 2x squared plus x minus 6. Multiply the first and the last together, and that gives you a -12. So we got -12, and the middle number is a 1. So this is going to be 3 times 4. 1 has to be a negative, so we're going to make 3 a negative because -3 plus 4 gives you a positive 1. Okay, and this middle number is a positive 1. So now what we have is we got 2x squared, bring down the minus 6, and in the middle, you're going to use minus 3x plus 4x. Factor by grouping. So greatest common factor here is x. So this gives me 2 x, and this gives me a -3. All right, and here I take out a 2. So I take out a plus 2, and this gives me 2x, and I take out a 2 from this, and this gives me a -3. So what I notice is x and the plus 2 is being multiplied by the same binomial. So beside it, I'm going to put, y'all, x minus 3. Okay. So on the bottom, I get this, x plus 2, and here I get 2x minus the 3. Okay. So now what I'm getting here, look, these cancel out, and I'm left with this. Okay. So the answer choice there is going to be, let's see, minus. This one right here, H. That's our answer. Okay. All right. So now let's do this next one right here. Number 4. So number 4, we have x minus k, and we have y minus k. And we're going to use the FOIL method, FOIL, to multiply, because we're multiplying here. So multiply these two together. So this is going to be x, y. Outer is these two. This is going to be a negative kx. In the middle, this is going to be, inner is going to be a negative ky. And last is going to be a positive k squared. So here I get xy minus kx minus y, is plus k to the second. So my answer choice, when I look at this, I can't combine any of the terms. And so that's going to give me minus. That's this one right here. That's h again, okay? So this is my answer. I can't combine any of these. None of these are alike, okay? So this is my answer for number 4. This is number 5, okay? I'm going to use distributive property to multiply. So when I use distributive property, I'm going to do it on here. This is going to give me 6. When I multiply, that's 6. X to the 4, that's 4 plus 3, which is 7. Okay? All right, and then we're going to multiply this. This is a -2. This is 4, 5, 6. X to the 6. We're going to multiply the last. This is 10. It's positive 10. This is 4, and this is 1. So this is x to the 5th. So your answer choice here is going to be this one. We got 6. Yep, C. Okay. All right, which is going to make this true? Which value of x is true for the equation? So we factor this to see what the values of x are. So here we go. So x in each, and then we got -12 here. This is 1, +1. So we got 3 and 4. In order to make this a positive, this has to be a negative. -3 plus 4 gives you a +1. So we're going to use -3, 4. So this is -3 here and +4. So when I solve this, let's set this equal to 0. I add 3 to both sides. That's going to give me x is equal to 3. When I solve the second one, I subtract 4 from both sides. This is going to give me x is equal to a -4. So these are my two answers, +3 and -4. Okay, +3 and -4. So this is my answer there. Okay. All righty. Let's look at this one. Okay, you're going to add these together, add these two terms. So the like term is, we got 3x plus this negative. Let me do this out to the side. So I have 3x plus a -2, well, 3x squared, sorry. They're like terms, so I can add these together. And so this gives me x squared, okay? So that's first, x squared. Okay, so now I'm going to add the like term for this one. It's going to be this. So this is 4x plus a -x. So this gives me 3x. So this is plus 3x. So now I add this one. -1 plus is in the middle, 3, +3. So this gives me +2. So this is +2. So this is my answer right here. Okay. All right, let's look at this one. It says the height of the flare from the gun can be described. This is a quadratic function where t is the time in seconds and h is the height. Okay, so this is the total height and this is the time in seconds. How long will it take for the flare to reach 36 feet? So this is when h is 36. So type it in to figure out. I'll type this in my equation. Or I can substitute, well, no, because 36 feet would have to be where this is equal to 36. So you have to type this in to figure the answer out. So we're going to do -16 x squared. And we have, what's this? Plus 60x. Okay, type it in. Now go to second table and see when y is 36. Y is 36 right here, so it's going to be 3. It takes 3 seconds to get there. Okay, so 3 is going to be your answer, D. Which quadrant contains this equation? Okay, so look. So we know that it crosses the y-axis. It crosses the y-axis at 11. All right, so let's graph it to see what quadrant it's in. So we got -2, and it's a downward parabola because it's the x squared term is a negative. It's -8x plus 11. Now let's graph it. All right, so let's see. Which quadrant contains the vertex? So let's go up to see where the vertex is. It looks like it's in quadrant 2, right? So window, we need to go up some more. The y-axis needs to go up. Let's go up to 20 and see what that looks like. Yep, the vertex is way up here. This is the second quadrant. So it's quadrant number 2. All right. How many solutions? That means how many times does it cross the x-axis? So grab it and see. Clear that out. And we got -3x squared plus 27. Okay. All right. So remember, this is y, where y is equal to 0. Graph it and see how many times it crosses the x-axis at 2 places. So it has 2 solutions. 2. Okay. It's never going to have infinite number of solutions. It's either going to have none, it doesn't cross the x-axis, one, that means it crosses at one place, or two. It's going to be one of these answers, but it's not going to be infinitely many. That's a crazy answer. All right, for a quadratic function, that is. What is the range of a quadratic function? Range is going to be how tall it is, okay? All right, so how tall is it? So we can do this. Type it in and figure out what the range is. This is x squared plus 4. And this is an upward parabola. So we know it's going to look like this, okay? It's an upward parabola. So it's going to go from this point on it to from this point right here on up, okay? On the y-axis. So it's going to be this to infinitely many, okay? So we typing it in, x. Okay, now graph it and see where it is. Okay, so we're looking for this point right here. So this is second trace, and we're looking for the minimum value. Okay, so let's go on the left bound here. Let's go on the other side here, and then press enter. Oops, you know what, I did that wrong anyway. Left side of that parabola, Miss Reyes. Really, Miss Reyes? Really, Miss Reyes? The left side is this side, and the right side is the other side. Okay. So this bottom number is negative 4. So it goes from negative 4 on up. So it's negative 4 to is greater than or equal to negative 4. So y is greater than or equal to a negative 4 because it starts at negative 4 and it goes up. So y is greater than or equal to a negative 4. That's my range. That's how tall it is. That's your y. So greater than or equal to is this one right here. Greater than or equal to a negative 4. That's B. Okay. What is the range for this? Your domain is where x is greater than 5. Okay. What's your range? All right. So do the same thing again. Oops, my bad. Negative 2x. I'm confused as to why it's saying. Oh, I know what it's saying. Okay, never mind. I had to read that again. I was like, what is it saying there? So type it in under y equals and let's graph it. It wants to know what is the range when 5, because when your x values are greater than 5. So x values greater than 5. Let's go to my table. X values are greater than 5. Okay, so your x value is greater than 5 is right here. Mm-hmm. So anything after that for your y. So y is negative 45 and it keeps going down. So it's from negative 45 on down. So you see that? Negative 45. So y is less, it should be less than, y is less than negative 45 because it's going to keep going, it keeps going down. So less than 40, oh, it's this one. And why did I choose that? Because look, it's telling you that it has to be that your x value has to be 5 right here. You see it, that your x value has to be greater than 5. So greater than 5, that means 5, that means 6, 7, 8, 9, so on and so forth. Okay, that's what that's saying. That's crazy. That was weird wording, y'all. Weird wording. This one's Wednesday. All right, what is the next now equation that describes this sequence? So let's see. So we got 3, -3, -2, -1. Then we got 0, 1. So that's plus 4. And then this is plus 4. This is plus 4. So we're adding 4 every time. So that's this one. You're adding 4 every time. Okay, you're adding 4 every single time. All right, define the explicit form. That's a y equals equation for this right here. Okay, so let's see from here to here, what is it going up by? This is going up by $1.50. Okay, so you're adding $1.50 here, and this is going up another dollar. So it's going up by $1.50 every time. So the slope here, your M here, is $1.50. So what's the starting amount? Work backwards. What's the zero number? So we got 5 um, minus $1.50. So look, watch. Or you could have typed it in and did linear regress. You could have typed this in and then do a linear regress. So we got 5 minus 150, and that's 350 as the starting amount. But they don't have 350 as the starting amount. So, hmm. Mm, wait. All right, so since they have the starting amount of this doesn't work. So what you have to do is basically choose one of these numbers, plug it in. But I can tell you right now it's B. And I know it's B because they got the N minus 1. Because they're starting with 5. You see, 5, if they make 5 the starting number, they really started with the first number, not the zero number. So they use N minus 1. And you multiply that times the 150, which is the slope. So instead of putting 150, just 150 in, they put n minus 1. They put 150 times n minus 1 plus the 5. Because they started off with the first number instead of starting off with the zero number. So this is the actual answer. And you can plug in any of these n values and your c should equal these. That's another way to check it. All right, so let's do this. Given a two-way table, choose which statement below is false. Okay, so the number of boys in the survey is more than the number of students with two siblings. Okay, so the number of boys in the survey, the total number of boys in the survey is 29. Okay, the number of boys in the survey is more than the number of students with two siblings. Number of students. These are two siblings, and it's 21. So number of boys in the survey is more than, yes, it is. It's 29 and this is 21. So this is true. Okay. 10% of the students that are girls have one sibling. Okay, girls with one sibling. So we're looking at girls, and it's 10 girls that have one sibling. So it's 10% of the students, all the students together. Okay, so we got 10, and all the students combined is 56. So we got 10 over 56. So let's do that. What percent is 10 over 56? 10 divided by 56. That's 17%. Look, move the decimal twice. That's 17.8%. And how did I know that it's 10% of the students? This is false. How do I know it's false? Is because it says 10% of the students that are girls with one cent. So 10% of the students. So let's look at this. It's 10 students, but it's not 10%. It's just 10 students out of the total number of students, which is 56. This is actually 17.85%. So it's not 10%. It's 10 students, but not 10%. It's 10 students, but not 10%. All right, so this one, the percent, so this is the one that's false B. The percent of only children that have boys is about 50. Only children, okay. Only children, this is, okay. Only children that are boys. So go up to boys. So it's 7 out of 29. So we got 7 out of 29. So that's, wait a minute, that's not right. The percent of only children that, oh, wait a minute, that are boys. So this way, 7 out of 12. My bad, y'all. 7 out of 12. Yeah, so that's about 58. Okay, so that's right. The percent of girls in the survey. So let's look at totals over here. 27 out of 56 girls. Out of 56 total. 27 divided by 56. And that gives us 48%. So that's right, 48%. So this is the only one that's false. Relative frequency, and I'll go over this is because our last unit is on that actually. A relative frequency table, which given a relative frequency table, which statement below is true if there are 80 students who took the survey? So it's a total of 80 students, okay? So these decimals represent percentages. All you just do is just move the decimal over 2 spaces to the right. So 5 students from class 3 failed the test. So we got class 3 failed. So we got 80 students. So we're just going to say 80 students times 0.05. Okay, so that's four students. 5 students from class 3 failed. Yeah, so that's not right. It's actually 4 students here. Okay, and then 28 students from class 2 passed. Okay, class 2, this is passed. So we got 80 times 0.35. That's 28. So this is right. Okay. 90 students passed the total test. So we got total test over here. Pass is 0.9. It says 90 students. This is that's 90%. Okay. So 0.90, times 80. This is actually 72 students that passed. 72 students. So far B is the one that's right. 4 students are in class 2. Class 2 total is 40%. That's 80 times 0.4. That's 32. So this is actually 32 students that are in that class. All right, so the only one that's right is B. All right, and that's your homework help, okay? If you have more questions, feel free to ask questions tomorrow, all right? Okay, have a good one.